Go. Okay, for today, you see how they have a parabola? Except it's different. How is it different? The shading is the purple part. It's not just a parabola, is it? It's a parabola, except it's been shaded. Is it shaded under it or over it? Look what I've got zoomed in here. Is it shaded under it or over it? Yes, under it. And why? Because there's a less than sign. Look at this one. This time the yellow is the shaded. Instead of shading, like thinking of it a different way, think of it as under or over. Which way is this shaded? Over it or above it. And that sounds like greater than, doesn't it? So it's kind of intuitive that way. All right. Now, when it gets more complicated is when you're shading two different lines and trying to figure out where you are. All right, tennis ball lab. We just threw the ball up in the air today, so if you missed today's class, you just have to have somebody record you throwing the ball in the air, and all we really need is that you have recorded the second that you let it go, and also be able to see when it hits the ground. That way, when you go back into the pictures and you go to edit, a lot of people don't know that. You're in the pictures, you look at edit, and then you can scroll across the bottom. And if you've got the latest version of the iPad software, you can see the 1/10 of a second that you let it go, and to the 1/10 of a second when the ball hit the ground. All right, good enough. The lab is going to use the format for all labs, which we will use all year. And the sketch is worth a couple points. Purpose, you can lose a couple points there. Procedures where you describe it in words, and calculations is where you actually have your equations all solved, and that's the hardest part for this lab, of course. All right, so look at the different functions that they have here. They have g of x as equal to f of x, and f of x is less than g of x, and f of x is greater than g of x. And of course, that's like, they'd use words like below or above. And I think it's easiest to look at one. So let's actually look at one here. We look at this one right here. Now we got a parabola and we got an absolute value. And I'd like you to do what it says here. I'd like you to put in a star here. Just like by doing this is good enough. Okay. Another star where they touch. Because where they touch is a big deal. That's where they're equal. Next, I'd like you to color in red where f of x is less than g of x. Keep in mind, the f of x is this one. I'm going to say, let's make this one blue. The absolute value, let's make it blue. And this is f of x. F of x is the blue one. Okay? Because it's a lot easier to say, when is the blue one less than the black one? See, this one's the blue one. When is the blue one less than the black one? Color in that area in red. All right, when's the blue one less than the black one? In here and in here. Now, the way we usually say that, math-wise, is we say in this zone and in this zone. Do you agree the places I boxed in is where the blue one, the absolute value, is less than the black one? Just look in just this box. You see how the blue one is less than the black one? Okay, now what's that box? Negative infinity until, should it be the -1 or should it be the 2? It's the -1. In that interval, between negative infinity and -1, it's a left to right thing. It's an x value thing. The blue one is less than the black one. Yes?
Should -1 have a bracket?
It's a good question. This is an interval, and at that moment, at that exact moment, They are equal to each other. So when those two touch, do you agree at that moment they're equal? They're not less than the one?
Yes.
Okay. So actually it should be a parenthesis. So this is not one of those times when you get to just go like, parentheses and brackets don't matter. They do matter. How could this problem have been different if you wanted it to be a bracket? If it had said or equal to. If it had said or equal to, then at the moment where they touch, which was at x is -1, at that moment, if it said or equal to, then we would have used a bracket. Okay, but we didn't, so I'm going to take that bracket off. There was not an or equal to sign, so that matters. All right, so how about the other one? Well, same kind of deal. From something to something. Gio, what did you say? It's okay, I didn't mean to catch you off guard, just asking somebody. Should we try Nora? What's this left or the right side? F of x is less than, this is the one we're doing right here. We're saying when is f of x less than g of x? And I'm just asking for what should go in here. What's the other place where f of x is less than g of x? Joe, do you know this answer?
1 comma positive infinity.
1 comma positive infinity, good. Because from this point on, it will stay lower than the other one. All right, I'd like to do another one like that. Everybody, make another XY chart. We're going to make another function. It's going to be another parabola. And then we're going to call the parabola f of x. Make it red. Well. I'm going to restrain myself. So we have a very strange noise in the classroom. So, okay. I'd like to now make another line like this. And that's a simple function. It's a straight line. We're going to call it g of x. Pause for a second. So you would need to know that that's at spot, let's say 4, 1. The spot where they cross is critical. And this spot right here, let's say that that's at -4, 5. Okay. There, I got my 2 important points labeled. Now you should be able to answer this question on your next test. When was f of x greater than g of x? I could have said that the other way around, but I asked, when is f of x, the red one, greater than g of x? So greater means above. So I could have just as easily said, when is f of x above g of x? And the way I do this is I change it in my head to, when is the red one above the blue one? Okay? And then it's a lot like last time. There's that zone, and then there's this zone. Gio, can you tell me one of those 2 zones?
Yeah, -infinity to 5.
Negative infinity to, you're close. It goes to the y, okay, there you go. It goes to the x value, not the y value. And should it be a bracket or a parenthesis? Parenthesis. If this had an equal to, then at that moment it would be equal, and then you would want to include that, so you'd have a bracket if there had been an or equal to. Okay. And Olivia, can you tell me the other one over here?
4 infinity, no brackets.
4 to infinity, because of that 4 right there, no brackets. I like it. Good. Question?
You want us to write the answer with the union sign, the final answer?
Yes, whenever you put 2 sets of parentheses next to each other, of course in these scenarios there can't be an intersect, right? So it would always be a union between the 2. All right, let's do one more. And this one, I'm just going to draw quick. You do not have to copy me. You just have to figure out the answer. That's f of x. This is g of x. This is at 4, 3. This is at -6, -2. My question is, when is f of x greater than or equal to g of x? In a moment, I'll ask you to compare what you think the answer is with the kid next to you. When is the red one bigger than or equal to the blue one? All right, pausing for a second to give you a chance to chat with the person next to you. What do you think? So let's see how you did. I hope you said that f of x will be greater than g of x in this zone right there, which would be from -6 to 4. But this time, since it says or equal to, brackets. Raise your hand if you had that one right. Okay, cool. Any questions about that kind? Let's move on. I think we've covered all of the things that you'd need to know for this. Imagine for a moment we were going to graph this. Well, I would graph the absolute value, shifted 1 to the right. Everybody carefully graph that. And then where is that greater, otherwise known as above, the line y equals 3? I'm going to change to red. There's the line y equals 3. Now where they cross is critical. And I'm just going to show you by algebra how I can figure out exactly where they cross, because these are kind of hard to read from a distance. So watch how I do this with algebra. X minus 1 is greater or equal to 3, and x, this is really, really important now, x minus 1 is less than or equal to -3. You see what I did there? This equation is exactly what you see when the absolute values drop. This equation is exactly the same on the left side. And by the way, if we wanted to, we could have put this negative on the left side. It doesn't matter. Just one of the two sides has to go negative. And then when it does, 3 is just changed to -3. Do you get that's like multiplying by a negative? And that makes this sign switch around? All right, so then I can go +1, x greater than or equal to 4. And +1, x less than or equal to -2. Look, I know my two important spots without having to find them on the graph. But I could believe that that's probably at -2, and this is probably at 4. Does that seem believable to you? Okay. And then those are the two important spots. But when is the blue one above the red one? Well, from 4 over this way, which would be from 4 to infinity. And it's or equal to, so I put a bracket. And the other part would be this part, like from here over this way, which would be from -infinity until -2. Again, a bracket because it says or equal to. Union sign in between. Final answer. Holy cow. You had to know absolute values. You had to know a new little twist of when this side becomes the opposite, you switch the sign around to be able to accurately figure out what these points are. Could you have gotten them off the graph? Yeah, you could have. You just had to be really careful about your dots and where you put them. You had to know that they were or equal to's because of this, and therefore brackets here and here. See, some people wonder why pre-calc is so complicated because it's got so many little parts. It's not like each of these parts is that hard. Like, oh, less than or equal, you need a bracket. But if you don't know that one little thing, that's all it takes. You got 6 things to know. Make one mistake, lose it. All right, let's just do one more like that. Everybody, I think you'll find this one mildly interesting. Y equals 2 is one of your lines. Y equals 5 is one of your lines. And in the middle, let's do this one in blue. Y equals absolute value of x minus 1, which is just a V shape that's been shifted. Go ahead and graph those 3 and try to figure out, hint, when is the blue one between 2 and 5? I'm going to use green for the where they're between. Would you agree in that little green zone that the blue one is in between the 2 red ones? And about those spots, -1 seems like one of them and the other one seems like -4. Do those make sense as key moments? Well, -1 right here would make this 2, which matches up with that 2, which kind of makes some sense, right? So I'm just checking if -1 and -4 like kind of make sense. If I put a -4 here, then I'll end up with a 5 here because it's absolute value, and that'll match this 5 here, and that makes sense. So how do you say the answer? Well, the question is, when is the blue one between the red ones? From -4 to -1. And is it or equal to? Ooh, tricky business. It's or equal to on one of them, which is the one where it's about the 5. So, oh, okay. So in the one that's about the 5, I better use a bracket. Which one makes it like the 5? That one does. So I use a bracket there and a parenthesis here. It's also in between there, there, and so that's at 3, and 6. So I'm going to say, if I use the 6, that's the one that's related to making this 5 here. And so between 3 and 6, and the 6 is the one that's like this. And so that's the one that gets the bracket, and this one gets a parenthesis, and this one gets a union. And there we go. Pretty sure I got it. If you can prove I'm wrong, I'll listen. Anybody get the same exact thing as me? Quite a few people did. Okay. Any questions about that one? All right. Would you agree graphing the V shape is pretty easy? It's just a V shape shifted 1 to the right. And those 2 lines, y equals 2 and y equals 5, those are pretty easy to graph, right? Technically, one of them should be a dotted line. Which one technically should be a dotted line? Yes.
Y equals 2.
Yeah, this one should technically have been a dotted line. But remember, it didn't really matter much because we were trying to figure out where the one is like under the other one. And that would have helped me figure out which one of these needed to be a bracket here and which one actually wanted to be a parentheses. And the one with the 6 and the one with the -4, those were the ones that were brackets. And you can see better now that I made it a solid line versus a dotted line. Okay. Don't need a master of this yet, but if you had to graph weirder things, this is telling you some steps, and there's a reason they tell you these steps, because if you just tried to graph this and graph that and see where they cross and stuff, it would be really messy. So instead, we set one side equal to 0. So let's go do that on number 1. I'm going to subtract the 3 and add the x to both sides. And I'll get 2x squared plus x minus 3 is less than or equal to 0. Now, why is that smart? Because now you got a parabola, and now you got y equals 0. So it's like whenever the parabola is below 0, and it'll be pretty easy. But how are you supposed to know where the parabola hits the x-axis? Oh, if you can factor it, you should. I think you're catching on. 2x and x. Everybody take a moment and try to figure out what would have to go where so that I can figure out these x-intercepts, also known as the roots, the zeros, the solutions. What does this factor to? Got to be good at factoring. That's why I was pounding on the top 20 at the beginning of the year. Because now, if you don't know how to factor, you're stuck. It can still be done with quadratic formula, by the way. All right. By this point, you should have figured out that there's got to be 1 plus and 1 minus. Joe Tadros, tell me how I know that.
Because it's a negative at the end.
Yeah, this number comes out negative. Therefore, one of them, and only one of them, needed to be negative. And now, what are the two numbers that I use? Nick? 3 and 1. If I just slap them in here and try it once, it'll either work or it won't. Did I happen to get lucky and put them in the right spots? Yes, I did. Because the outside and the inside make positive 3x and negative 2x, and that makes a total of plus x. If I had been wrong, I would have been able to just switch the signs around. If I had gotten the exact opposite of what I wanted, I could have switched the signs around. If I had not gotten the exact opposite, if I had gotten something completely different than what I wanted, then I would have switched the numbers around. So it's always best to just stick a couple numbers in, try them, and see if they really yield the same middle term as you wanted them to. So yeah, you know my two answers. It's x equals negative 3 over 2 and x equals 1. That must be these two guys. 1 and negative 3 over 2. I obviously was just kind of like slapping those in. I didn't know exactly where this was. And now I can figure out when is the parabola bigger. No, what's it less than? It's a less than 0. See, less than sign right there. So when is it less than or equal to 0? When is the parabola less than 0? Oh, it's in this zone right here. Another way to say it is like this zone right here. And that's from negative 3 over 2 until you hit 1. And then I got to figure out whether it's brackets or parentheses. And it's an or equal to, so it's brackets on both ends. And there was your answer. Okay, this will find your weaknesses for you. If you don't know how to graph, that'll get you in that way. If you don't know how to factor, it'll get you in that way. At some point, once you have it graphed accurately, it's really not too hard to see where one function is below or above the other function. Okay, so we're in the part where we're starting to do your homework. Let's just talk this one last question through. Notice, no graph. How could you do this without a graph? Otherwise, you could have shifted a V-shape left 3 and then had a line at y equals 5 and then just tried to tell, where they crossed. But if you don't do it that way, you do it this way. X plus 3 is less than 5. And so critical, everybody write the other one. It's not x plus 3 is less than 5 again. Sasha, what would it be? What's the other equation?
X plus 3 is less than minus 5.
You're close. It's a sign issue. It's not a less than.
Oh,
Greater than -5. Notice when this becomes a negative, the sign has to switch because it's kind of like we multiplied by a negative. When you multiply by a negative, the sign switches. So one of these is less than and one of these is greater than. X is less than 2. X is greater than -8. If I were to graph them, and then it talks about testing intervals, sometimes people don't teach it the way I do. Some people just have you figure out the two numbers, and they say, test the intervals around this and figure out what works. And they would say, let's test 0 and see if it works. So you stick 0 in the equation, and it's pretty quick to see that 3 is less than 5. Hey, it worked, so therefore I should shade in here. But the way I taught you was to say greater than this, so I knew it had to go bigger than that. And less than 2, so I knew it had to go less than 2. And that's just another way to do it. Strongly recommend doing some homework tonight, but I can't make you. Have a great day.